Well, welcome to the solving by undoing portion of the notes here. You should have already kind of started with just some practice of order of operations. I know that's taken you back a few years, but it's also a good base for us as we start working with this solving by undoing process, a kind of a method that we're going to use, which is called this do-undo table. It's nice to have that work in terms of order of operations down before you do that. So that's a good introduction to the here, but the first thing we kind of want to do as we work through this is go through and talk about your inverse operations and your inverse functions, because that very much is involved when we're using this solving by doing process. So first of all, just to talk about an inverse. Uh, when we say that we have an inverse of something, and it's kind of the most intuitive definition here that we'll go with, that will serve us very well for these problems, is that this is you simply use one thing to undo another. So when you have your inverse operations, those most students at this point have been working with for quite a long time. You only have four operations: add, subtract, multiply, and divide. So as you start looking at your inverse operations, we have to pair different ones together, right? So if you need to undo, say, addition, we pair that with subtraction. You use subtraction to undo addition, and vice versa. Same thing with multiplication division, right? We pair those together. If we need to undo division, say we're dividing by 3, we simply multiply by 3 to undo that. So this idea of inverse operations, using one to undo another, is something you've been doing for a long time. But we also want to start to talk about inverse functions and start pairing different ones together. Now, here's one thing about inverse functions, okay? Inverse operations, there are only 4 operations, 2 pairs. Problem with inverse functions, there are lots. There's lots of different types of functions. So we're obviously not going to do all of them, but we are going to pick and choose which one we're kind of use and go with here on a regular basis, right? So our first one here is a pretty common one, right? If you have something squared, how do you want to do that? You take the square root. So that's one. Once again, goes back to algebra 1, if not before then, in terms of what you use. But remember, it goes the other way too. So that arrow is pointing both ways. If I have a squared and I need to undo that square root, I would use a square. Just like that, we have cube and cube root. If I have a cube, if I cubed something to undo that, I use the cube root. Or if I have a cube root, I do that by cubing something. Typically both sides of the equation. We can think about this more generally as well. These are really just called power functions. Cubes and squares really fit into this definition as well. And we'll see some examples later on where this power function idea, where we kind of use a power function to undo a power function, will come back into play. We'll come back to that one. Some other ones that we're going to use, some trig functions. So if you have sine of x and you need to undo that to solve for x, we would use inverse sine. You also see it as arc sine, but for our purposes, we're just going to use the inverse sign with a little -1, which looks like it's an exponent. But really, it's indicating an inverse. And you see that in your graphing calculators or your scientific calculators. You see that same one. Same thing with cosine and inverse cosine. Use one to undo the other. Typically, sine and cosine, you're taking those angles, taking sine and cosine of an angle. So inverse sine, inverse cosine will undo that, and it will take the ratio and give you the angle. There's some other information we're going to talk about in terms of what's called principal angles from a graphing calculator related to trig functions. We'll come back to that at a later time. The last big set of inverse functions that we're going to do here is your exponents and logs. These are always the tricky ones because students don't want to always connect exponential and logarithmic functions as inverses. They don't even sound like they go together, but they very much do. They go together, as much as addition and subtraction do. So we have to keep working with those. These are ones that you've used in the past and will continue to do so as well. So if I have an exponential equation, say b to the power of x, I need to undo that, solve for something in the exponent, I use a logarithm. And I would have that same base b as the base of my logarithm. If I have something like a e to the power of x, right, that x is in the exponent, need to solve, I'm going to use natural log because it's a base e. And once again, I can go the other way. If I have a natural log of x, let's say, I could rewrite that as a base e, or if I have a log of some particular base, I could rewrite that as an exponential equation as well. So we'll see once again some other examples later on of those. But for today's purposes, in terms of these first two videos that you have here, we're really going to stick with a lot of the squares, square roots, cubes, cube roots, and your four operations. So we'll deal with trig functions, exponents, and logs later. All right, so getting into the solving by undoing. First off, you need to know there is a particular structure of the equation by which this method works extremely well. And that's when you simply have a single variable to isolate. Like when you visually look at that equation, you see one variable that's there. There's not multiple times where that variable shows up, like you don't have an x squared plus x equals 10. You see those two different terms, x squared and x. There are other methods to solve those. Typically factoring is a great one. But we're not factoring here. We want to solve by undoing. So we want a single variable. To be able to solve those or isolate those single variable, we're going to use what's called a do-undo table to help organize our work and give us a path through this. So when you look at the table, the left side of the equation, or sorry, the left side of the table, we're simply going to identify the order of operations. What's being done to that particular x value? And once you've identified what those order of operations are to that particular x value, you can then decide how you would undo those, right? All those operators and functions have inverses. And we always do that in the reverse order. That's what solving is. Solving is simply looking at the order of operations and undoing those order of operations in the reverse order. So this do-undo table is going to help you organize your work to see how would you solve that equation. Okay, so let's try it for a couple of examples. Specifically, we're going to start with the first two examples. We're actually going to take this first set of 6 problems right now, so 19 through 24. I'll do 2 here, and then you can kind of work on some. We'll come back together and do the last 4 on a separate video. So the first thing is I'm going to set up my do-undo table. I got the left side is do, right side is undo. And when I decide the do, the order of operations, I look at the variable x in this case. There's only one of them there, right, that I need to isolate. I look and see what's being done to x in terms of the order of operations. So the very first thing is when I look inside parentheses, I would have to add 4. It's the very first thing. And to undo adding 4, I simply subtract 4. So that goes on the undo side. Then after that, after I would add 4, the next thing is, in terms of order of operations, I'd have to multiply by 2. I'm still working in the numerator. And that kind of that grouping symbol idea. So to undo multiply by 2, I divide by 2. Lastly, I can now divide by 5 as the very last step. So to undo divided by 5, I multiply by 5. So all those pair together on the right side. Now when I'm undoing those, I undo those in the reverse order. And what I am going to or what number I'm using is the 12. What's on the right side of the equation? What constant? That constant that's by itself. And I can simply run up that right side of the undo column. That would tell me exactly what do I need to do to 12 to solve this. So I'd multiply by 5, divide by 2, subtract 4. Now what I'm going to do is, even though we have this table, we know how to solve it, we're still going to show the work off to the side from the equation. So the first thing I do is multiply both sides by 5. If I do that, I end up with 2 times the quantity x plus 4. Divide by 5 is gone because I multiply by 5, and I multiply 12 by 5 and I get 60. Then I keep working up the right side of that undo, and I move from multiplying both sides by 5. Then I divide both sides by 2. That will undo the multiply by 2, so I'm left with x plus 4. Take 60 divided by 2, and you end up with 30. Lastly, I would subtract 4 from both sides, so I have x equals, because the plus 4 has now been undone, and I subtract 4 from 30, and I get 26. So there's my answer. Now that was hopefully a pretty simple example to start from, but if you weren't quite sure how to get that done, then this do-undo table can help you. It's not the only way to solve that particular problem, but it's definitely one way to do it. All right, so let's do number 20. We'll get this one going together, and I'll give you a chance to work on some on your own. So set up your table, your do and undo. Start with the x and look and see what's being done to that in terms of the order of operations. So first thing I have to do is I would simply multiply by 3, right? I'm looking inside the square root, and I would multiply by 3. Then my next step after I multiplied whatever x is by 3, I would then need to take the square root. And lastly, I would add 92. Now when I go into the undo side, I think of those in the reverse order. So to solve this, I'm going to have to subtract 92 first. Then I have to undo the square root, so I'd square it. And lastly, I would divide by 3. And all of that would start by doing it to the number 100. variable was on the other side of the equation, on the opposite side of x. So let's do all of those things to that equation to isolate the variable. So my first step, subtract 92, start with the last thing. So if I subtract 92 from 100, I get 8 equals square root of 3x. The plus 92 is gone. I've undone that. Next, I need to undo the square root, so I square both sides. Square 8, I get 64. Square the right side, the square root is gone. I'm left with 3x. Lastly, divide both sides by 3. So 64 thirds would be my answer, but if you don't want to, because 3 doesn't divide evenly into 64, but if you want to, you can leave it as a decimal, and we'll typically go out to 3 decimal places on these. So 21.333 would also be an acceptable answer in this case. Okay, so I'm going to stop there, and I'm going to have you do numbers 21 through 24. Try those on your own. Take a little bit of time, and once you're done, there will be a follow-up video where we just go through those for examples, and you can check your tables and you can check your work. But I do want you to go ahead and do the table, this do undo table, and show the work like we did in these first two. But believe me, later on, once we get further on in this process of using this table to solve by undoing, I'm very much we eventually want to drop having to write out this table because I don't want to double up the work here, right? So we'll eventually not do the table and just have it be something that's like a thought process for you to think through these different problems such that you can have a plan of attack once you start solving the equations. Okay, so go ahead and do numbers 21 through 24 on your own, and then watch that next video to check your answers on each of those.